Students, can you hear me, students? Can you hear me? Right. Right. Okay, students, today we are going to discuss organic chemistry. We are starting organic chemistry part in our syllabus. Okay. So, first of all, remember, students, organic chemistry means is not just an unit, one unit. Organic chemistry is made by 4 units in your syllabus, right? Actually, unit number 7, unit number 8, 9, and 10. So these 4 units are representing organic chemistry, right? So unit number 7 is basic concepts of basic concepts of organic chemistry, and unit number 8 is hydrocarbons and halohydrocarbons. Halohydrocarbons. Unit number 9 is oxygen containing organic compounds. And unit number 10 is nitrogen containing organic compounds. So these are the 4 units that we have to discuss under organic chemistry. Remember, student, so this is the lesson plan now. So when we consider our lesson plan, I'm going to divide these 4 units into 2 parts. Organic chemistry part 1 and organic chemistry part 2, right? Under the organic chemistry part 1, we are going to cover this topic, unit number 7. Under the organic chemistry part 2 only, I'm going to cover unit number 7, 8, 9. Okay. So this is the lesson plan in organic chemistry, right? We have part 1 and part 2. Keep that in your mind. So that means you will have 2 tutorials. 2 tutorials. Additionally, sometimes I might send you some other tutorials, but let's see, right? Mainly you will have 2 tutorials. So I sent you 1 tutorial, and the second tutorial, so you will receive that one soon after the completion of unit number 7. So our main target is to cover unit number 7 as soon as possible. Then we can cover these 3 topics in the second tutorial. Now, when we go for the contribution from this unit, right? So let's talk about the contribution for the exam paper. So this is what you have to understand mainly. Contribution for the examination paper. I'm talking about the 2023 A-level examination paper. In 2023 A-level examination paper, they have given 9 MCQs from organic chemistry, right? So let's take, there are 10 MCQs, only 1 MCQ difference. So therefore, let me take 10 MCQs. Right. So students, we know that 10 MCQs means direct 10 marks. Am I correct? Direct 10 marks. Right. Minimum they will give 9, 8 MCQs. Huh? So therefore, maximum there will be 10 MCQs. Then definitely there will be one structured essay question. So that one structured essay question carries 5 marks directly for your result. Then there will be definitely an essay question in part C. The first question is essay, organic chemistry. So that question carries directly 7.5 marks. Directly 7.5 marks. Then what is the total marks for your result from organic chemistry? 22.5. Look at the scope, 22.5. Remember students, this is actually huge, right? We consider this one is a huge part of chemistry lessons in our syllabus that we have, right? So actually the highest contribution for our examination is from physical chemistry units, equilibrium, kinetics, gas laws, energetics. So from those units only we have the highest contribution, about 40%. But in organic chemistry alone, these 4 units giving 22.5 marks for the examination paper. You have to understand, first of all, right? These 10 MCQs are very easy. If you have practiced isomers questions separately with me, actually in the structured essay question, they are giving isomer question. In this lesson, we are going to discuss about isomers. I'll tell you what are the things we have to discuss on the isomers. And I'm planning to discuss 2011 to 2023, all the isomer questions separately with you. Because most of the students are telling that isomers are difficult, but I'm going to say you that, I'm going to prove you that isomers are nothing. It will take some time. In order to do the isomer question, it will take some time. But even though we are spending some time, if we can go for the correct answer, then we are certain about our marks. So therefore, we have a special preparation for this structured essay question, isomer part. And the next one, essay. Essay is actually students considered this question as conversions. Some of the students are thinking that organic chemistry means conversions. Organic chemistry again conversions. No, it's not like that. In organic chemistry, actually, we have discussed many things. Several question patterns are there. I'll discuss that one after this. There are so many question patterns from organic chemistry. You have to remember that. Okay. I'll tell you what are the question types that we have to discuss. Can you understand? So in essay question, we have mainly conversions are there, reactions are there, reaction mechanisms are there, and some other organic theories will be tested in the essay question. So students, you can easily get this 22.5 marks. That means about 21, 22 marks will be there for organic chemistry. That means if you have covered this organic chemistry lesson perfectly, and some of the other questions, when you do that one, you can easily go for S marks, S pass with organic chemistry, right? But we have to go for A. But I'm telling you that this 22 marks, 22.5 marks is actually very easy. You can easily score this whole 22 marks very easy. So that's what we are starting today. Very, very important. And one more thing, remember that most of the students are doing organic chemistry nicely, perfectly. But when they're going for the examination, they think that, right, before you go for the examination, you think that organic chemistry is very easy. I can do that one. So some kind of overconfident, right? I'll consider that one as overconfident. Sometimes in the examination, you are scoring for the difficult lessons that you mentioned. You consider some lessons as difficult, especially your physical chemistry, equilibrium lessons are difficult. You think in that way, right? So, but when you go for the examination, you can't answer for the organic chemistry questions in the examination time. So there is a huge problem with the students actually. They think that organic chemistry can be done easily, right? So we have to give a special concentration on this topic. We have to cover these things perfectly, right? So this is the contribution for your examination paper from organic chemistry. Can you understand? Right? So this is the lesson plan and the contribution for your examination paper. And the next thing is, students, let me tell you that how that organic chemistry questions are coming to our examination paper, right? Question patterns, you have to know that one too. What are the question patterns? Question patterns from organic chemistry, right? The first question pattern is IUPAC nomenclature. We are going to discuss about IUPAC nomenclature under this unit number 7. So unit number 7 is actually mainly cover that IUPAC nomenclature, and the next one is isomers. Number 2 is isomers, right? Isomers. So this is the second question type. And the third question type is, we have some identification test. We have some identification test to discuss here in order to identify primary, secondary alcohols, in order to identify aldehyde ketone, in order to identify alkynes. So likewise, we have some identification test. We are going to discuss them separate. And the fourth one, we have to discuss about organic reactions. Remember, students, there are we can't actually count them. Uncountable reactions are there, right? So we cannot say that this number of particular reactions are there in organic chemistry, but in your syllabus, they have included more than 40 reactions. We are going to discuss these 40 reactions separately in the class, right? I'm going to discuss these reactions 2 times. Can you remember I conducted some organic therapy sessions? So I'm going to conduct that one with you all from the beginning again. So at there, I'm going to revise those reactions for the second time, right? So in that organic therapy session, my intention is to give you the proper practice of the reactions and the conversions, because reactions and conversions are not two. Actually, we consider them as together, right? When you know the reactions only, you can do the conversions. So therefore, let me consider. I'm going to consider that fourth type is reactions, right? So the question pattern 5 is considered as reaction mechanisms. Reaction mechanisms. That means how the reactions are made, how the compounds are made, right? In the organic chemistry, we are going to learn some reactions like electrophilic addition, nucleophilic addition, electrophilic substitution, nucleophilic substitution, acid-base reactions, eliminating reactions, free radical reactions. So likewise, so many reactions are there. Under those reactions, we are going to discuss mechanisms, how the reactions are. And the last type only, the question type is conversions, right? First of all, I want to tell you that, students, organic chemistry is not equal to conversions. Conversion is a part of organic chemistry. Actually, a question type of organic chemistry, right? After you learn these reactions and the conversions only, you can do the reaction conversion in the examination paper, right? That means you have to cover all the reactions. I told you, there are about 40 reactions, right? There are about 40 reactions. You have to learn these 40 reactions properly, and we are going to practice some conversions. Then only you can do the conversions that they have given in the examination. When you analyze the past few years, 2023, 22, and 21, the organic conversions that they have given is very easy. Easily can be done. But when you analyze before 2019, 18, 17, 16, 15, they have given some difficult conversions also, right? So we don't know what is the pattern they will give, but we have to prepare for everything. So therefore, I'm going to discuss conversions in detail. So I'm going to discuss so many conversions with you along with the reactions, because you have to remember all the reactions, then only you can do the conversions. So remember, students, These are the question patterns that you will have under the organic chemistry lesson. Especially when you go for the IUPAC nomenclature, there will be one MCQ. Always they are giving in the examination every year. In the first 10 MCQs, there will be an IUPAC nomenclature question. So therefore, you have to get ready for that one, right? In order to do that MCQ, you will realize how much practice, how much things we have to know. In this lesson, you will realize. And you will realize that in order to do isomer question, how much you have to learn, right? Because sometimes in order to draw an isomer, you have to know these reactions and identification test also. Separately, I'm going to discuss some identification test in order to do the isomer question before we go for the reactions and everything. Right? Okay. So get an idea. This is the lesson plan that we are going to do. Okay. So first of all, let's go for the organic chemistry part 1, unit number 7. What is it? Basic concepts of organic chemistry. Right? Take the tutorial. So I believe that you all got the tutorial, isn't it? Anyone here didn't get the tutorial? Actually, I posted all your tutorials on Monday. So therefore, I think that all of you got the tutorials. You didn't get? Okay. So those who didn't get the tutorial, so Dulki, yesterday only I got to know that you joined for the class. So I will send you a tutorial also, right? And another one was there actually. I'll send you tutorial soon, okay? Right. Okay. Now let's go for the unit number 7. Basic concepts of organic chemistry. Now listen to this one very carefully, students. This lesson is very easy. I told you, as I mentioned you can score this 22.5 marks very easily. Mark my words, right? So the next coming units are sometimes you might realize those things are difficult. Kinetics are okay, but equilibrium-like lessons are somewhat difficult because calculations are there. But organic chemistry lessons are very easy. Theories are there, and that is interesting. Okay. Right. Basic concepts of organic chemistry. Remember, the first thing you have to know why they have given a topic like organic chemistry and what we are going to learn under organic chemistry. Remember, students, when we consider organic chemistry, actually under the organic chemistry, what we are going to learn is about carbon, right? Carbon containing compounds. Addition to carbon, hydrogen is also there, but mainly organic. The term organic means we consider that carbon containing compounds. Carbon containing compounds, right? Remember, students, there are millions of carbon containing compounds. Millions of carbon containing compounds. So, right, okay. So there are millions of carbon containing compounds. So among these millions of carbon containing compounds, we are going to discuss about some categories, right? First of all, we are going to categorize these organic compounds into few parts, right? We are going to discuss about mainly 15 types of organic compounds, 15 types, right? For an instance, we can consider alkane, alkene, alkyne. Then we have aldehyde, ketone, alcohol, carboxylic acid, ester, cyanide, alkyl halide, acid halide. So likewise, I'm going to teach you mainly there are 15 types of organic compounds that we have to discuss. Remember, as I told you, remember, there are millions of compounds. Among these millions of compounds only, we are going to discuss about these 15 types of compounds. Keep that in your mind, right? So therefore, Remember, this organic chemistry, that means carbon containing compounds can be seen everywhere. For an example, now go for the kitchen, right? In your house, you have a kitchen. So when you go for the kitchen, you know that gas cylinder is there, right? Students, give me a minute. Right. Okay. So remember, we are exposing to organic compounds in our day-to-day life. For an example, when you go for the kitchen, you can see the gas cylinder. So gas cylinder means actually in the gas cylinder, we know that it's containing LP gas, liquid petroleum gas. So the liquid petroleum gas is containing, what is it? A mixture of propane and butane, right? Propane and butane. Remember that propane and butane, both of them are carbon containing compounds. If I draw the structure for the propane, propane is look like the CH3, CH2, CH3. If not, let me draw that. Look at this one. There are 3 carbon atoms. All the carbon atoms are connected to hydrogen atoms. There are 8 hydrogen atoms. So this is propane. So when you consider butane, there are 4 carbon atoms. I'll teach you how to name these compounds. So this is butane. See, so these are organic compounds. Can you understand? And we can take another example. When you go for the petrol stream, right? We know that octane is actually liquid petroleum, petrol. Octane, we have 92 octane, 95 octane likewise. So petrol means octane. Octane is also, we can consider an organic compound. So the molecular formula is actually C8H18. That means there are 8 carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8. All of them are connected to 18 hydrogen atoms in this way, right? So when you consider polythene, we know polythene. So polythene also what? Some kind of a polymer which is made by an organic compound, right? You have learned polythene. You have learned about polythene under the polymers in your O-level time, right? So we have a lesson known as polymers under the unit number 14 in industrial chemistry. After the industrial chemistry, we have separate part as polymers, right? So this is also what? An organic compound, right? So the paint, wall paints, organic compounds, right? Plastic compounds, organic compounds, right? Medicine that we are taking, when you go for the pharmacy, you take some medicine, paracetamol, amoxicillin. So likewise, medicines are there. So those actually containing organic compounds. Let me draw the organic molecule of paracetamol. So that means in our day-to-day life, we are dealing with these organic compounds, but we don't know whether they are organic compounds or not. That means mainly carbon is there in most of the compounds. That's why I told you that millions of carbon compounds are there, uncountable, right? And you know that, students, carbon's valency is phonic. Look at this one. Now this, I have started a carbon chain. That carbon is connecting to another one, another one, another one, another one. So likewise, this can be continued unlimitedly. Ne? So therefore, we can say that millions of compounds are there. Can you understand? Right? You know that soap, we are discussing about the production of soap. So soap is also containing an organic compound. It is an ester, right? Sodium derivative of carboxylic acid. So likewise, in day-to-day life, we are exposing to organic chemistry everywhere, right? So therefore, very, very important to discuss about these carbon containing compounds. That's why they have given a name like organic. Organic means simply carbon containing compounds. But addition to carbon, we consider here hydrogen also. You will see there in most of the compounds, hydrogens are also there. So organic chemistry means the study of carbon hydrogen containing compounds, mainly carbon containing compounds. There are millions of compounds. In order to discuss, we can't discuss about millions of compounds separately. So therefore, we are categorizing some compounds. In our syllabus, actually, we have only 15, around 15. Okay. So when you go for the university to study or chemistry, you will again learn about organic chemistry. There will be so many reactions that you didn't learn in A-level time. Okay. So therefore, we actually limited here. We only discuss about some limited compounds and limited reactions. So you have to learn them properly. Mark my words, this is very interesting, right? So from the day one, try to understand these things properly, learn these things interestingly, then organic chemistry will be nothing for you, right? And I want to tell you that when I'm doing A-level also, my favorite part was actually this one, organic chemistry, right? Not only for me, but for many chemistry students actually, if you ask the most interesting part is organic chemistry, right? So my teacher taught me organic chemistry very interestingly. So I'm following that method and I'm going to add some new things, new techniques, and let's finish this one very quickly. Okay, right. Now go for the tutorial. If you don't have the tutorial, please refer the PDF that I've uploaded to the WhatsApp group. Page number 2, turn to the page number 2. The branch of chemistry that studies carbon as an element and the compounds that form by carbon is called organic chemistry. Please highlight that one. I told you that mainly we are going to discuss about carbon containing compounds. So these carbon containing compounds are known as what? Organic chemistry, right? So the study or the branch of chemistry that we are discussing, that we are studying about carbon containing compounds is known as organic chemistry, right? So please highlight that one. The reason for the separate study of carbon is the large number of compounds formed by the carbon. So as I mentioned so when you consider a particular carbon chain, carbon, 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 so this is continuing. So right, so we can't say that this is stopping here like that. We have learned about the polymers also. When you discuss about the polymers, many polymers are made by this carbon, right? So therefore, so many carbons are there, large number of compounds are, right? So in the second point, they have given why we should study organic chemistry, because there are so many compounds are there, large number of compounds, we have to study them. The large amount of carbon forming compounds that are used in daily use, such as foods, medicine, textiles, cosmetic, etc. I told you, we are daily exposing to organic molecules in our day-to-day life. So these are some industries actually, they are using organic chemistry, right? Foods, medicine, textile, cosmetics, etc. Right? So they have given some examples. So quickly fill the tutorial. Example. As a food component, carbohydrates, you have already learned about these things in biology, right? Fats, proteins. So these compounds are containing carbons, neither. Can you remember? Then we have plastic materials, right? For plastic materials such as PVC, polyvinyl chloride, right? Then we have polythene. I told you now. Polystyrene. Then polyesters. We are discussing these things in polymers. Then nylon, Nylon also organic compound, carbon containing compound. So the main element is carbon. So the next one is medicine. In medicine, remember friends, actually, most of the medicines are made by these carbons, right? Take paracetamol. So paracetamol also a carbon containing compound. Aspirin, yes. Penicillin, amoxicillin. So these are carbon containing compounds. And then we discuss about the fuels. Yes, most of the fuels that we are using are carbon containing compounds. Petrol, diesel, kerosene, liquid petroleum gas, LP gas. So these are some examples that we are using organic compounds molecules in our day-to-day life in industries like food, plastic materials, medicine, fuels. Quickly complete this one. Quickly. Right, okay. Are we done? Yeah. Now let's see why carbon is forming this much of large amount of compounds, right? Why? What is the specialty between carbon and these compounds? Why carbon is forming this much of large amount of compounds, right? Look at the first reason they have given. So reasons for carbon to form a large number of compounds. So let's see one by one. You have to remember these things, right? The first reason is actually, students, remember carbon can form, carbon is special. Can you remember in this first, second unit, we learned that under the Lewis structures, carbon is forming single bonds. Carbon is making double bonds. Then carbon is making triple bond also, right? So all the types of bonds are formed by carbon, right? So later we are going to learn this, all the single bond compounds, alkanes. If it is a double bond, we consider alkene. If it is a triple bond, we consider alkyne. Ane, ene, ine, right? So likewise, we are categorizing carbon containing compounds. So therefore, carbon can form single bonds, double bonds, triple bonds. So this is one of the reasons that carbon can have a large amount of compounds, right? So let me write down this one here. In the tutorial they have given, carbon can form single bonds, single, double, and triple bonds with its atoms. So this is the main reason, no? This is the main reason that they have. So what is the second reason, right? Second reason, carbon has the valency for, and there are many ways to complete it. Students, when you consider second period elements, in the second period elements, the main valency, the highest main valency belong to carbon, right? Can you understand? Because nitrogen's main valence is 3, 5 is also there. But nitrogen is not forming 5 bonds. Carbon is forming 4 bonds. Nitrogen can form only 3 bonds. So therefore, it has the valency 4. That means 4 bonds can form, and there are many ways to complete it. Write down the examples. I have given you space to write down these examples in the tutorial. Write with me. Number 1, carbon can make 4 bonds, 4 single bonds in order to complete the valency 4. For an example, let me give here an organic compound like here. This is the first organic compound you are learning, students. Can anyone tell me what is the name for this one? Methane. Simply, this is methane. Here is the first organic compound that you learn, methane, right? I'll tell you that why we are using these kind of terms. These are known as prefixes. We have meth, eth, prop, but, pent, hex, hept, oct. Likewise, we have some prefixes. So those prefixes are added according to the number of carbon atoms inside that compound. Since there is only one carbon atom, we consider this one is methane. Then tell me, if there are 2 carbon atoms, what it should be? What it should be? After methane, we have ethane. If there are 3 carbon atoms, then propane. If there are 4 carbon atoms, then butane, pentane, hexane, heptane, octane, nonane, decane. Understood? Right? Like this. So the second way that we carbon can complete the octet is carbon can form 2 double bonds. We have discussed these under the Lewis structures also. So we can consider a simple example, carbon dioxide. Carbon dioxide. Students, tell me, right, I'm going to ask you a question. Is carbon dioxide an organic molecule or inorganic molecule? Is carbon dioxide organic molecule or inorganic molecule? Actually, it seems that carbon is containing, so therefore we can consider this as organic molecule. But we can categorize carbon dioxide under inorganic molecules as well. Because we discuss about carbon dioxide, especially under the group number 14, carbon-containing compounds. So therefore, so there is no wrong if we categorize this one either in organic or inorganic, right? So whatever it is doesn't matter because carbon is there, right? If you want, you can categorize this one under inorganic. If you want, you can discuss this one under the organic also. I'm going to discuss a reaction related to the carbon dioxide under organic chemistry, which they haven't given in our resource book. Remember, sometimes you might feel that, sir, you are teaching something not related to our syllabus. Don't think like that. Students, when we are learning organic chemistry also, we had the same issue when our teachers are teaching, but they told that be patient. We are learning something that important for the questions. The questions patterns are different. Understood? So, so therefore, we are learning few things that not mentioned in the resource book. You follow the resource book, all the things will be discussed, but addition things are also there, right? You will understand that one by the time. So carbon dioxide is another way that you can see that carbon is making 2 double bonds. Another way to complete the valence 4. Then you know that it can form 2 single bonds, 1 double bond. So the example molecule, let me take this one as C double bondo HH. Remember, students, this molecule is very famous. This is known as methanol. Methanol. IUPAC name is methanol, but we know that trivial names, common names are also there. So the common name for this one is formaldehyde. 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 Okay. So some of the memes are also there in social media. You can see that formaldehyde and the casual aldehyde. Formal, casual, likewise. So they have given some memes also. You can see that one, right? For organic chemistry, there are many memes. I will share that one. So this is actually methanol. The common name is formaldehyde, right? And we know that the next method is definitely carbon triple bond. Let me erase this one. carbon can make triple bond in order to complete its valency. But along with the triple bond, there will be a single bond also. So we can consider examples like in this way. So the remember students, this is alkyne. If there is a triple bond, we consider that compounds are alkyne. So this alkyne is known as ethine. What the name? Ethine. If it is alkyne, we have the suffix "ine". So the common name that we are using is acetylene. Acetylene. No? So these are the ways of completing the valency form of carbon atom. Therefore, it can make so many compounds. When you consider the aldehyde, there are so many aldehydes, right? If you consider the alkanes, there are so many alkanes, right? So this is only just one category, another category here. And this is also another category. There are many molecules, there are many compounds with this structure. Can you understand? That's why carbon is making so many compounds. Quickly draw the examples. Done, right? Then go for the page number 3. Next page, they have given the third reason that carbon can form bonds with oxygen, nitrogen, sulfur, phosphorus, and halogens, and compared to silicon, which is in the same group, carbon forms strong bonds. Remember, students, this is also one of the reasons that carbon can form so many compounds. When you analyze the Lewis structures, many Lewis structures, right? I can say that 75% of Lewis structures are containing carbon, right? So under the Lewis structures that we discussed under the second unit, we didn't discuss that much. Yeah, we didn't discuss about organic molecules there. We discussed only about some inorganic molecules. Neither. So remember, carbon can connect to many elements. Carbon can connect to hydrogen. Carbon can connect to nitrogen, oxygen, fluorine like halogens. Carbon can connect to the same group, silicon also. So likewise, carbon can make bonds with so many elements in the periodic table, especially the second period and the third period elements, because its valence is 4, right? Directly carbon can form 4 bonds with the others. Now, when you consider fluorine-like element, that is limited. Fluorine, chlorine-like elements are mostly they are forming single bonds. When you take oxygen, mostly it's forming double bond or else single bond. But carbon is making 4 bonds, right? So therefore, carbon can make bonds with the others than the other elements. So that's what they have mentioned here, right? Look at the third point they have given. Look at the third point they have given. Carbon can form bonds with oxygen, nitrogen, sulfur, phosphorus, and halogens. And look at this point. Compared to silicon, which is in the same group, carbon forms strong bonds. Yeah. Carbon can make strong bonds, right? Because triple bonds are there, double bonds are there. Naturally, carbon is very strong. Neither. What is the natural 2 substances we learn? Graphite and diamond. So therefore, the natural existence is very hard. So therefore, carbon can make so many strong bonds with the others. So that is also one of the reasons that carbon have so many compounds. In your resource book, they have given a table. Let me draw that table with you. Sir, do we need to remember these values? Students, I would say better you remember these values, because sometimes in MCQs, these values will be important, right? So that's up to you. Carbon-carbon single bond, carbon-carbon double bond, carbon-carbon triple bond, carbon-hydrogen bond, silicon-silicon bond, silicon hydrogen bond, right? If you have the resource book with you, take out the resource book, right? Refer the resource book also. Check the values that they have given. Carbon-carbon single bond, energy is 346. Carbon-carbon double bond, 610. Carbon-carbon triple bond, 835. Carbon-hydrogen bond is 413. Silicon-silicon bond is 226. Silicon-hydrogen bond is 208 kilojoules per mole. So likewise, you can see that these are the values for the bond energies. All of them are positive values, you know that, because we are breaking the bonds, right? Now, if I draw the brown boundary line, look at the difference. These are actually bonds formed by carbon. These are the bonds formed by silicon. Look at the silicon-silicon bond energy and carbon-carbon bond energy. Here, the silicon-silicon bond energy is 226, but carbon-carbon bond energy is 346. So that means the bonds formed by carbon is very stronger than silicon. Silicon is also same. Okay? After carbon, what is next? Silicon. So therefore, even though that a small atom than silicon, it is making bonds with large energy. Try to understand this. Okay. Especially better you remember carbon-carbon single, double, and triple. Right. So this is the third reason that they have given why carbon can make so many molecules. Right. So quickly come to this one. Yeah. If you have any doubts, put your doubts in the chat box. So why does the energy increases when the number of bonds between carbon increases? Lashmi, that's very simple thing. We have discussed this one already. Just imagine, have you seen that the people who are doing karate, they are breaking the, look at it, right? Stones and everything they are breaking, right? So when they are breaking those things, so here we have just imagine there are 3 stones. Just imagine there are 3 bricks, here 2 bricks, and here only just 1 brick. So to which one we have to give high energy to break? This one. Triple bond. Here carbon-carbon triple bond. So triple bond energy is greater. Can you understand? We know that we have discussed the hybridization, sp and sp. Sp orbitals are very shorter. So therefore the bond length is actually shorter. So when the bond length is shorter, the bond strength is getting higher, then it's very difficult to break. You have to give a lot of energy to break. When the number of when the number of bonds are increased between the 2 atoms, the energy is also increased. Okay. So I memorized the values. Yeah, it's a good thing. Huh? If you can memorize these things, values are good. But Asma, check whether in the next week, before next week, you will remember these things or not. Huh? Right. Okay, so this is the third point that carbon can make so many bonds. Now let's go for the fourth point, number 4. So what is the fourth one they have given? This is something related to polymer students actually. Carbon can form long linear chains. Look at this one. Carbon can form long linear chains. Right? Long means actually lengthy. Linear means we can consider a continuity is there. Let's see. The first example I'm going to discuss here, write down that one in your tutorial, polythene. So this is the simplest example that we can take. We know that the repeating unit of polythene is this one, CH2, CH2. N times means this is repeating N times, uncountable. It can be 100, it can be 1000. Likewise, N value will be a large value. That means it's repeating. That means it is lengthy, long, and linear, continuing. So therefore, polythene kind of molecules are formed by carbons, carbon atoms. So therefore, long linear chains are formed by carbon. Second one, let me take here. No need to be worry about these things. So what is this hexagon? Wait, we are going to discuss about it. Wait a minute. Remember, students, this is considered as a polyester. This is also repeating N times, right? So in this compound, actually, this one also carbon containing compound. I'll tell you what is it exactly. So this is polyester. So this polyester also, you can see that it is continuing. N times means we can't guess what is the number. It can be the 100, 1000, millions. We don't know. So therefore, this is an polyester, a long linear chain, uncountable, right? So this is actually we are using daily, right? I think there is no one doesn't use this one. Everyone is using this. Tell me anyone here is not using this one. What is this? Carboxylate anion of sodium salt. If not, so that is the technical term, right? So hereafter, when you go for the washroom, you are using soap, liquid soap or whatever soap you are using. So that soap is what? Sodium salt of carboxylate anion. You go for the shop and ask from Mudalali, Mudalali, can you give me a piece of sodium salt of carboxylate anion? I don't know what will happen to you, right? Probably if he knows chemistry, then this is good for you. What is this? Soap, right? This is soap. Understood? We are going to discuss about the production of soap in unit number 14, industrial chemistry. Very interesting, right? You can make soap at your home, right? What you need is actually coconut oil and some sodium hydroxide. Understood? Coconut oil and some sodium hydroxide. If you have that one, you can make soap at home. You try, yeah? Try. Read the industrial chemistry book and try. And you can't use that soap. The homemade soap cannot be used to wash our body and everything. Okay, so you can use that one for wash the floor vehicles. Likewise, you can use that one, right? So the homemade soap cannot be used to wash our body, right? Don't do that one, right? Okay, so this is actually, these are polymer, students. Make C17. C17 means how many carbon atoms are there? 17 carbon atoms are there, and 35 hydrogens are there. And hereafter again we have carbon atom. So this is long linear chain. So soap is also one of the example that we can discuss, that carbon is having long linear chains. See, this is the reason, right? This is the reason I told you that carbon is having many compounds. They can form long linear chains. Quickly write down these three examples. Quickly. Okay, ne? Right. Right. Students, now in the fourth reason, here we discuss long linear chains. That means these are long linear chains. These are actually open chains. That means you can see starting and the end can be seen. But remember, some of the ring type of closed rings are also there. Ring type closed chains are also there. Right? So the fifth reason, right? So actually you have to be wonder. So the things that carbon can do. So the next thing is carbon can form ring type closed chains. This is also one of the reasons that carbon have millions of compounds. Ring types, close carbon chains. Right? Let me draw. Right. So this is the first time you are going to discuss about benzene. Have you heard about benzene? Benzene. You go for the school laboratory. Ask from your school teacher, chemistry teacher, can you show us some benzene? Benzene is actually a kind of a pale yellow color solution, liquid. Vaporizing, that is organic compound. That's a liquid, right? So the structure of benzene, it's look like this, students. Look at this, Anilu. May benzene is containing 6 carbon atoms in this. Okay. Addition to 6 carbon atoms, there are 6 hydrogens as well. In order to complete the octet, we can see that there are 3 pi bonds. This is actually known as benzene. What is the molecular formula of benzene? Tell me. What is the molecular formula of benzene then? C6H6. Empirical formula is just CH. Molecular formula is C6H6. This is benzene. Can you understand? Right? So, as we discussed, the point is ring type. Yeah, this is a ring type. Ring ekak wage. Close carbon chain. This is a carbon chain which is containing 6 carbon atoms, but it is closed. Unlike the previous examples we discussed. In soap, in polythene, and in polyesters, we discussed those carbon chains were open chains. You can see the starting and the end. But here, can you see the starting or the end? Oh. Because these are closed ring type of chains. So the main ring type of carbon chain that we are discussing is benzene. Remember, students, we have a separate discussion for the benzene. If you have the resource book, you go and check under the hydrocarbons and halohydrocarbons. We have a separate discussion for benzene. This is resonance stability of benzene. What are the electrophilic substitution reactions done by benzene? Friedel-Crafts, acylation, alkylation, nitration, halogenation. Likewise, we have many things to discuss under benzene. Remember, these things are very easy. So let's remember, so there is a specialty actually with the benzene molecule. I will remind that one here. I want to discuss that one with you here. Can you see that there are 3 pi bonds? May? There are 3 pi bonds. The way that benzene is denoted is not exactly like this. The mehema liyala inna bෑ karadarai, right? We can't write down the benzene ring in this way. We have to draw the shape hexagon and we have to mention all the hydrogen atoms. So such a pain. So therefore, what we are going to do is we are going to denote the benzene molecule in this way. You draw a hexagon and mention the pi bonds in this way. So then what about the hydrogen atoms? Do we mention that one? No need. You can just draw in this way. This is the benzene molecule that we are going to discuss. So the only ring that belongs to you at this age is what? Benzene ring. So therefore you have to remember this one. Can you understand? And remember, addition to this one, we can write down the benzene ring in this way also. Draw the hexagon and this kind of a circle inside the benzene. Why? Can anyone tell me why did I draw this circle inside the benzene ring in this way? I discussed this one under the graphite. Yes, because of the pi bonds. May students, inside the benzene ring, you can see that there are 3 pi bonds. Pi bonds means actually these are very weak bonds. So the electron clouds are remaining in the p orbitals. So what will happen is these 3 electron clouds are mixing. So the correct term that we are using is delocalizing. What is the term that we are using? The pi electron cloud of the benzene ring is delocalizing. Delocalizing කියලා කියන්නේ වටේ යනවා. කොහෙද යන්නේ? වටේ යනවා. බෙන්සීන් රින් එක වටේ යන්නේ. හරි. වෙන කොහෙවත් නෙමෙයි. බෙන්සීන් රින් එක ඇතුලේ වටේ යනවා. So therefore what will happen, since the pi electron cloud is delocalizing, we can tell that the benzene ring is more stable molecule, right? So we discuss about the stability of the benzene ring later, right? I told you we have to separate, we have a separate discussion of benzene later. So just imagine why we are denoting the benzene ring in this way. Can you understand that one? Why I am denoting the benzene ring in this way? I drew a hexagon. Inside the hexagon, I drew a circle. The reason is there are 3 pi bonds inside the benzene ring. These 3 pi bonds are delocalizing. That means kind of mixing these 3 pi bonds, making an electron cloud. That electron cloud is delocalizing. Again, then that is common to everyone. Right? So in the examination, you can draw the benzene ring in this way, either this way. Right? So draw it nicely, okay? At the beginning, we have seen that students are drawing these benzene rings nicely, but at the end of the lesson, actually, we can't figure out whether it is benzene or not. That much your drawings are what? First. So therefore, don't do that one. Draw it nicely, okay? So this is actually ring type of carbon, ring type of close chain carbon molecule. So the molecule that we're discussing is benzene. Okay. So addition to this one, let me draw another one. Second example. So look at this one. This is also a kind of benzene, but it's not exactly benzene. Very similar to the benzene. Here we can see that HNCl. Okay. In this way. So this is also ring type name. You can see that there is no open chain. This is a ring type chain. Close ring type closed carbon chain. Right? So the name of this compound is actually known as hexachloro hexane. Don't worry, we are going to discuss about these names later. Hexachlorohexane. Remember, hexa means actually 6. Chloro means chlorine. You can see that there are 6 chlorine types. 1, 2, 3, 4, 5, 6. There are 6 chlorine atoms. So therefore, hexachloro. Hexane means 1, 2, 3, 4, 5, 6. 6 carbon atoms are there. So that means nothing we are going to mention about hydrogen. Yes. And one more thing, students, remember, when we are drawing the organic molecules, we don't have to mention the lone pairs and the correct shapes. Now just imagine, this is one of the example organic molecule we are discussing. This is a carboxylic acid, known as 1,2. This is ethanoic acid. If not the simple term, that trivial name is acetic acid. In vinegar, we have this molecule, CH3C double bond OH. So do we need to put the lone pairs in this way? And do we need to mention that trigonal planar shape in this way? Right? Don't do that one. No need to mention those things. We are not drawing CH3C double bond OH in this way. So this is the way that we are going to draw that. Okay. I'll tell you how we can draw the branching and everything. We'll discuss. So CH3. Now this is CH3. There is a bond here. So we can write down this one in short form. In short, we can write down CH3. These are known as alkyl groups. Okay. So let's discuss those things later. Right. So try to understand. This is also one of the reasons that carbon is having large number of molecules. What is it? Ring types, close carbon chains. Draw these 2 examples quickly in the page number 3. Done. Eh? So can we change the positions of the benzene ring? Yes. Kopeshani, we can do that one. So is there anything specifically denoted by the ring at the middle of the benzene? Nothing. We can consider it is kind of a pi electron cloud. That's all. Nothing to mention there. So benzene is yellow or colorless. Uh, we can consider, yeah, mostly it's kind of a pale yellow වගේ කියන්නේ පොඩි ලා කහ පාටක් වගේ තියෙනවා. But sometimes we can see that one in colorless also. Right? So we can consider colorless or else pale yellow. නේ ලා කහ පාටක් තියෙන නිකන්. ඔව් ඒවා එකත් හොඳයි. හරි. So are we done with this one? Shall I erase? Now you have to write down everything quickly. Huh? If we finish this lesson as soon as possible, we can do that, students. Organic chemistry part 2. That means unit number 8, 9, 10 along with the kinetics, unit number 11. Right? So I'll try my maximum to finish your syllabus in April. Wage. I think that we can do that one. So let's see. So because 27 badges coming in April, I guess. So therefore, when they are coming, actually your syllabus should be finished. That is my plan. So I'll try my maximum. Yeah, before that, in April, we can finish that one. Okay. So therefore, we have to work hard. Right. Third one. Look at the third example. So this is also a kind of a ring type of a molecule. Right. You can check that everyone is satisfying the octane. No one is unfollowing the rules that we learn under the Lewis structures. Here the thing is we don't mention the lone pairs. No need to mention them, right? Otherwise, carbon oxygen atoms are satisfying the Lewis structure, may octet, and hydrogens are connected to the carbon atom through a single, right? Remember, students, this molecule is known as actually, I don't know whether you have heard about this one, cinnamaldehyde. Do you know what is cinnamaldehyde? Cinnamaldehyde is actually the chemical compound containing in cinnamon. So we can obtain this one from the bark of the cinnamon tree. So bark means actually a potta. ඒ කියන්නේ කුරුඳු ගහේ පොත්ත මේ අපි ගලවලා ගන්න. So therefore this is cinnamaldehyde, right? So this is aldehyde because aldehyde functional group is this one, C double bond OH. මෙන්න මේ වගේ එකක් තිබ්බොත් if you notice something like C double bond OH, so that is an aldehyde, right? So you learn that one. And the fourth one, I think all of you have used this one at least one time in your lifetime. I think no one is there without using this one. What is this? Paracetamol. So this is the chemical formula of paracetamol. So there are also benzene ring is there. Ne? See, nitrogen atom is also there. Nitrogen containing carbonic compounds. All right. So these kind of compounds are known as amide. And here we have OH. So this benzene and connected to OH is considered as a phenol. Right. So this whole term is coming when OH group is there. So this is paracetamol. Right. Now don't go and check in the paracetamol tablet. There is this molecule. Huh? Don't find that one. Huh? You can't see this molecule. Right. Do you know that? Remember, students, when you go for the university, especially bioscience and physical, for the physical science, you won't qualify that one in our university, Columbia University. Pharmacy is there, right? In order to do pharmacy, in after A level also, remember, if you are free, that means until the examination comes, you are free. So therefore, you can follow some kind of a pharmacy course or pharmacy diploma because this is something related to chemistry, right? Pharmacy means actually we are studying about the organic molecules. We are discussing, we are learning about the medicines, and medicines are containing these organic molecules, compounds, chemical formulas. We are learning about these things. Pharmacology, right? In universities, there is a separate course. Special courses are also there. Pharmacy. You can be a pharmacist if you want, right? I'm also planning to do some kind of a pharmacy course in future, right? Remember, students, even after getting a degree, I'm thinking that I don't want to stop from there. We have to learn further. We have to collect, we have to update our knowledge. Don't limit it to one particular area, right? So we have some dreams, so go for those dreams, right? Try to be an entrepreneur. Don't try to work under someone. You can do something. You can start your own business after getting a degree. Understood? So come to that level. I'm also trying. Right. So this is actually examples for ring types of molecules. Quickly come to this. So no need to remember these things. Don't try to memorize these things. So are we having the extra class series from the next week onwards? Yes, Sinetma. So yeah, I'll make this announcement now. From next Tuesday, you will have extra classes. As I mentioned you, most of you have voted for Tuesday morning, 9 to 12. So the next class will be conducted Tuesday morning, 9 to 12. We are doing organic chemistry. If you can't attend for that one, doesn't matter. Since I'm giving you the recording, before the next Saturday class, you have to watch that one and come. Okay. From Tuesday to Saturday, you have some kind of a gap there. So therefore, you can watch and come, right? So are we mentioning the physical states when writing organic reactions? Yeah, that's a very good question, Lashmi. In organic chemistry, we don't have to mention the physical states. In inorganic chemistry also, I told you that it's not important to mention physical states in inorganic chemistry. Even in the organic chemistry, we don't have to mention them. Understood? So I have heard that if you do a pharmacy course, we can't do medicine. Is that true? If you are following medicine, I think I don't know about biology much actually. You have to ask that one for someone who knows about medicine and pharmacy, those who did medicine. But I think when you're doing medicine, actually, you have already the knowledge of pharmacy. Right? So since I did maths only, I'm someone related to chemistry and who did maths. So that's why I'm planning to do pharmacy. So if you are doing medicine, actually, I think no need to do pharmacy. If you want, I think you can do that one externally also, right? So now there is a trend, students, remember, double degree. I saw that in my university, actually, some of my friends were there. They are parallelly doing 2 degrees. That means this is our main degree, bachelor degree. And outside, they are doing some external degrees, right? I don't know how they are managing those things, but some students, some people are they actually they can manage double degrees, right? So you can search them after the examination, right? That hexagon shape is benzene in paracetamol. Yes, benzene. Asma, your father did both medicine and pharmacy, ne? See, that means you can do that one. Yeah. And Asma's father is a doctor actually. He did medicine and pharmacy together. That means there is a chance. Okay. Right. Learn everything before you die. Right. So the next topic is organic compounds. So let's go for the page number 4, organic compounds. Now we are going to discuss about organic compounds, and I'm going to teach you what are the categories of organic compounds here now, right? Since there are so many organic compounds in nature, it is difficult to study them separately. So classifying organic compounds makes it easier to study them. Remember, students, we are classifying the organic compounds since there are a large number of organic molecules. The simplest forms of organic compounds are called hydrocarbons. Actually, our next unit is about hydrocarbons. Hydrocarbons contain only carbon atoms and hydrogen as the constituent elements. Students, remember, now our subtopic is to get to know about the organic compounds we have to discuss. I told you what is organic chemistry, why we are learning organic chemistry, and why carbon is making this much of large number of compounds. Now let's see what are the type of organic molecules that we have to discuss, right? Under that, we have some categories. So the first category that we are going to discuss is hydrocarbons. Hydrocarbons. Look at the term hydrocarbons. When you look at the term hydrocarbons, what you really can understand here? Hydro means hydrogen is there. Carbons, yeah, carbons means carbon is there. That means hydrocarbons means simply we can tell that carbon and hydrogen containing compounds. Simply as that, containing compounds, right? Tell me one of the examples that we discussed. Up to now, we have discussed many examples previously. Methane, hydrocarbon, ne? Carbon and hydrogen containing compound. And I told you that benzene ring also hydrocarbon. Because we know that there are 6 carbon atoms connected in this way. Hydrogens are connected to all 6 carbon atoms. So this is hydrocarbon, carbon and hydrogen containing compounds. This is what we are going to discuss under the hydrocarbons. So look at this one. They have given a priority for the hydrocarbons. Most of the hydrocarbons are used as fuel, students. As we discussed, LP gas cylinder containing butane and propane mixture, a mixture of propane and butane, hydrocarbons. Then when you go for the petrol shade, we can see octane, 92 octane, 95 octane. So that is also hydrocarbon, C8H18. Can you understand? So likewise, so hydrocarbons are very, very important as fuels. They're using, right? So carbon and hydrogen containing compounds are hydrocarbons. Remember, these hydrocarbons again can be classified, right? Look at the classification of the hydrocarbon. I have given you space there. First of all, highlight that the simplest forms of organic compounds are called hydrocarbons. Quickly highlight that one. The simplest forms of organic compounds are called hydrocarbons. Highlight that. Then they have given hydrocarbons contain only carbon atoms and hydrogen atoms as the constituent elements. Highlight that one too. Hydrocarbons contain only carbon atoms and hydrogen atoms as the constituent elements. Now let's go for the classification. Classification of hydrocarbons. This classification is given in your resource book. I'm going to discuss the same thing, nothing else. You have to remember. So therefore, quickly draw this classification with me. Hydrocarbons can be classified mainly into two parts. The first type is aromatic hydrocarbons. Aromatic hydrocarbons. And the second type that we are discussing is aliphatic hydrocarbons. So these terms are actually strange for you. By the time these things will be familiar to you. Don't worry. Yeah? Aromatic hydrocarbons. This is known as aliphatic hydrocarbons, right? So first of all, I'll tell you that about these aromatic hydrocarbons, right? So do you know why this term aromatic is came? Actually, under the aromatic hydrocarbons, students, we are discussing about benzene and its compounds. Under our syllabus, there are so many aromatic compounds. In our A-level syllabus, we are discussing only about benzene and its derivatives. There are so many benzene containing compounds like toluene, phenol, nitrobenzene, chlorobenzene, bromobenzene. So likewise, there are so many compounds. So therefore, we are going to discuss about benzene and its derivative. Right? So benzene containing compounds. Remember, when you go for the laboratory, so I told you, so you ask from your school teacher to show some benzene liquid, and then she will take some liquid into the test tube and she will show you. You can see that some kind of a characteristic smell is there for the benzene. For the benzene, characteristic smell is there. You know the term aroma. Aroma means what? Aroma. Aroma means some kind of a smell. Right? Now, you know that Andunkuru, Sambrani, right? So they have some kind of aroma, right? Smell. So likewise, so these benzene compounds are having some kind of aroma, right? So that's why they have given a name like aromatic hydrocarbons, right? So the next type is aliphatic hydrocarbons, the opposite of that. Aliphatic hydrocarbons are, again, can be divided into two types. Look at this one. Aliphatic hydrocarbons can be divided into two types. What are they? So number one is acyclic, right? And the second type is cyclic, right? Remember, acyclic means we can consider that one is, those are not cyclic molecules. That means we don't have any closed carbon chain. We have open carbon chain. Here we have cyclic. Cyclic means ring type of carbon chains, right? So sometimes this is known as alicyclic, right? So remember, students, you have to be familiar with these terms. Huh? Look at this one. Hydrocarbons are two types: aromatic hydrocarbons and aliphatic hydrocarbons. Under the aromatic hydrocarbons, we are going to discuss about benzene and its compounds. That's all. Then we are done with aromatic hydrocarbons. Then under the aliphatic hydrocarbons, again we have acyclic and cyclic. Acyclic means open carbon chains. Open carbon chains. If you want, you can write down there. Cyclic means closed carbon chains. Ring type, close carbon chains. These are known as what? Cyclic hydrocarbons, right? That is coming under aliphatic hydrocarbons. Again, acyclic hydrocarbons are three types. What are they? These are the three major types. What are they? Alkane, alkene, alkyne. Alkane, alkene, and alkyne. Remember, students, if they have given the suffix "ane," and suffix "ene" and suffix "ine," you can easily identify these relevant compounds. If it is alkane, definitely you can identify that one because alkanes are containing always carbon-hydrogen single bonds. Only single bonds. Got it? Alkenes can be identified because carbon-carbon double bond is there. Right? Carbon-carbon double bond is there. Alkyne can be easily identified. Carbon-carbon triple bond is there. That's all. And the hydrogens are connected to the relevant carbon atoms. This is the way that you can identify alkane, alkenes, and alkynes. Alkanes are containing carbon-hydrogen single bonds. All of them are single bonds. Alkene carbon-hydrogens with double bond. Carbon-hydrogen with triple bonds. Right? So that double bond and triple bond is between carbon-carbon atoms. Carbon-hydrogen cannot make double bond or triple bond because only hydrogen is having one electron. So therefore, double bond and triple bonds are made by the carbon atoms. So these are the acyclic aliphatic hydrocarbons. Then what are the cyclic hydrocarbons? Cyclic hydrocarbons means carbon is making ring type of molecules. Look at this. Let me take that 6 carbon atom ring. This is not benzene now. Don't misunderstand. This is not benzene. This is known as cyclohexane. This molecule is known as cyclohexane, right? What is the name of this molecule? Cyclohexane. We are right. Cyclohexane, right? So likewise, we have some molecules to discuss, some ring type of molecules, except benzene under these aliphatic carbons, right? So can we take benzene under aliphatic hydrocarbons because it is also cyclic? No. I told you, under the main classification, we separated benzene. Benzene means aromatic. We cannot categorize benzene under aliphatic. Aliphatic means carbon-hydrogen atoms are there, except benzene, right? Under there, we have two types, acyclic and cyclic. Acyclic means open carbon chains. Then we have three types, alkanes, alkenes, alkynes. Under the cyclic, we have ring types of closed carbon chains. For an example, we can consider cyclohexane, right? So this is a kind of benzene buggy. So therefore, this is benzene. No. Right? Benzene means benzene. Right? You have to see that these 3 pi bonds, pi electron cloud. So likewise, you have to see them. So we don't have any pi bonds there. So therefore, this is something else. Can you understand? Right? Quickly draw this classification. This is the classification they have given in your resource book. Under page number 4, classification of hydrocarbons. Write down this one quickly. Right, okay, students, are we done? Yeah. Go for the next page. In that next page, I have given you not write down there. You're writing something very important. If you have any doubts, put your doubts in the chat box. Huh? Under the note, quickly write down. The cyclic organic compounds which are stabilized by forming a cyclic delocalized cloud of pi electrons are called aromatic compounds. Aromatic compounds, right? So I told you what does mean by delocalized cloud of electrons. So here we have some key terms, highlight them. Stabilized, cyclic, delocalized cloud of pi electrons. Next one, benzene, which is indicated by the molecular formula C6H6 is the simplest aromatic hydrocarbon. C6H6. If you want, you can write down C6H6 liquid. Physical state of benzene is liquid. Okay. Okay, right. Right. Now let's go for the next part. They have given that a point like the simplest hydrocarbon is alkane. Let's analyze basic information about the types of compounds using in alkanes. Remember, students, under the aliphatic hydrocarbons, I told you that there are three types: alkanes, alkenes, and alkynes. So alkanes are the simplest type of hydrocarbons that we are discussing, right? So therefore, we have a separate discussion of alkanes. First of all, I'll introduce alkanes. Then let's learn about the categories we have to discuss, okay? And I'll give you some idea about the isomers also using alkanes. Then we are going to discuss about all the types of compounds we have to discuss, right? Then they have given the definition for the alkanes. What are the alkanes? Alkanes are the hydrocarbons which are containing only single bonds, right? Alkanes are hydrocarbons that contain only single bonds between carbon atoms. Try to understand. Okay. Students, let me consider a few examples. Let's start from the first alkane. I told you. What is the first alkane? What is the name of the first alkane? Methane. Methane, right? Write it correctly. Methane. CH4. We can write down this one as just CH4. Molecular formula. So this is considered as methane. Right? So what is the second alkane? In the second alkane, what will happen is another CH2 group is adding here. Right? Same thing is written here, CH3. Another new CH2 group is added. And finally, hydrogen. Right? So that means we are adding another CH2 for this one. Then we obtain the next one. So this is known as actually ethane because there are two carbon atoms. Right? The first alkane is methane. Meth is representing one carbon atom. Eth representing two carbon atoms. Try to understand. Okay. The way that we are writing now, students, remember in organic chemistry, we don't draw the Lewis structures. We don't have to draw the Lewis structures. So now I'm going to give you these things because you are beginners though. So therefore you have to understand how these alkanes are made. So therefore that's why I'm giving these structures. If not, easily in the examination paper, in order to represent the ethane, you can write down CH3, CH3. Right? This is the way that we are writing. Right? Look at this one. Sometimes this can be very strange for you, unfamiliar for you. With the time, actually, that will be okay. Right? Remember, these are actually alkyl groups. We are writing the organic compounds with alkyl groups. CH3. Right? We can write down that one in this way. And the other CH3 in this way. Then CH3, CH3. Nothing else, ethane. C2H6. If not, we can write down C2H6 molecular form. Right? You have to be familiar with these things. And the third type, then what will happen? Again, another CH2 group will come to the middle in this way. That means another carbon atom is increasing. Then what it should be? So that should be meth, eth. The next one should be propane, right? You can see that the prefix that we have used is prop. Prop means 3 carbon atoms. 3 carbon atoms, right? So we can write down this molecule without writing in this complex way, right? We can simply write down in this way. Look at the way. CH3, at the middle we put CH2, no? CH2, CH3. Can you understand? This is the way that we are writing the short way of the propane molecule. CH3, CH2, CH3. Easy, ne? Rather than drawing these Lewis structures, we can write down CH3, CH2, CH3. If not, we can write down C3H8. And here we can see that this is C2H6. Can you understand? That is the methane, ethane, propane. And let me draw another one. First of all, quickly draw this. Next one should be butane. Quickly draw that one. Those who know, quickly draw it. Butane. Done, ne? how that butane should be drawn. Butane should be drawn, fourth one, in this way. Fourth one, butane. 1, 2, 3, 4. Ah, 4 carbon atoms are there. That means at the middle, we are adding another CH2. Right? So therefore, this is considered as butane. But. This is not but, but. But. But means we can say that this is 4 carbon atoms. 4 carbon atoms. Right? How we can write down the molecular formula in the short way? Right? Remember, you have to practice these things. CH3, this part CH3, CH2, CH2, CH3. Now, if not C4H10, C4H10. Can you understand? Butane. Butane. Right? So likewise, we can continue pentane, hexane, heptane, octane, nonane, decane. Right? Easy, ne? Methane, ethane, propane, butane. Methane is CH4, and then we saw that ethane is C2H6, propane is C3H8, butane C4H10. Quickly draw this one. Very easy, huh? This is the first type of organic compound that we are learning. Done, eh? Now let me draw a small table. Actually, you don't have to draw this one. So drawing these 4 molecules are enough. To get an idea, let me draw in this way. Alkane, number of carbon atoms, IUPAC name of alkane, molecular formula, then short form. If you have enough space in your tutorial, you just draw the table. If not, otherwise, no need. Right? 1 carbon atom. IUPAC name, methane. Molecular formula, CH4. Short form is also same thing, CH4. Then ethane. Molecular formula, C2H6. The way that we are drawing the short form is CH3, CH3. Then we have propane. Molecular formula, C3H8. CH3, CH2, CH3. Fourth one, butane, C4H10. CH3, CH2, CH2, CH3. Let me take 5, pentane, C5H12. CH3, CH2, 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 CH3. Last one. 6 is enough, huh? Hexane, C6H14. CH3, CH2, 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 in this way. Can you understand? This is the way that we are writing the alkanes. Okay. Students, did you understand a pattern in the molecular formula? There is a pattern. Did you observe that one? CH4, C2H6, C3H8, C4H10, 512, 614. With these numbers, actually, there is a pattern, right? Just imagine this is N. Number of carbon atoms are N. N equal 1, 2, 3, 4, 5, 6. Then number of hydrogen atoms should be, what is it? You have learned about number patterns from grade 9 in mathematics. Then tell me, suggest me a common formula. Suggest me a common formula. Suggest me a common formula for an alkane. What is it? Suggest me. Anyone here? Yes. Yes, correct. Very good. Very good, students. EMI. Very good. So we can write down common formula is CnH2n plus 2. CnH2n plus 2. How that become? Right? Now for an example, just take n equal 1. Then substitute here C1, 2 into 1 plus 2. That means CH4. Neither. N equal 2. C2, H2 into 2 plus 2. C2H6. N equal 3. C3, H2 into 3 plus 2. C3H8. Then we can suggest a common formula for alkane, which is CnH2n plus 2. If the number of carbon atoms are N, number of hydrogen atoms should be 2n plus 2. Remember, these common formulas are very important when we go for the isomers questions. Right? I'll tell you that one. Right? For some compounds, actually, I'm giving common formula. For the alkene, we can say that CnH2n. For alkyne, we can say that CnH2n minus 2. For aldehyde ketone, we have CnH2nO. Right? For the carboxylic acid and esters, we have CnH2nO2. Right? So likewise, we have some common formulas for the organic compounds. This is the common formula for alkane. If you see somewhere this kind of a formula, definitely that should be alkane. That means they have given C5H12. Now you have a confusion whether it is alkane or alkene or alkyne. Then apply for this one. Check whether this is N2N plus 2 or N2N or else N2N minus 2. Because alkene, alkane and alkyne are there. Addition to that one, what? Benzene is there. That's all. Then you can check and confirm whether you can confirm whether it is alkane or alkene or alkyne. Can you understand? Right? Okay. So what are the doubts you have? If you have any doubts, put it out in the chat box. So shouldn't the molecular formula and the short form change? No. Let me now okay, the Sinetma. Because when we asked to write down the molecular formula, this is the way that we have to write. We know that one. Let me consider this one is short form of the structure. Okay. Then okay. Yes, we have a question like this. Wait a minute. I'll answer for that one. Yeah, normally when you're doing organic, students have this doubt. Right. So now we have a doubt like this. Asma. So in the short form, can we write like this CH3, CH2, 5 CH3? Yes. Now, Yeah, that's also okay, fine. Now look at this one. Now let me take pentane, this one. So pentane, I drew the short form of the structure as CH3, CH2, 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 CH3 in this way. So now you're asking whether we can write down this one as CH2, 3 times CH3. Yeah, this is okay, fine. Right, that means CH2, CH2, CH2 repeating 3 times. So I have mentioned that one in even shorter way in this. Yeah, we can write down, but better write down in this way. Yeah? Right, this is the best way that we can write. Right, normally in the examination, they will give you maximum up to 7 carbon atoms. Right, even in the isomers, they will give you maximum up to 7 carbon atoms. In history, after 2011, they haven't given any isomer question exceeding 7 carbon atoms. Maximum 7. When we are doing the questions, you will understand. Got it? So therefore, students, try to understand. We can write down in this way also. So do we need to mention this hyphen? CH3, CH2, 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 CH3, likewise. Yeah, that's also okay, fine. Right? Doesn't matter. But when you're writing this one, what will happen is actually you are wasting the space again. Okay? So therefore, you can write down this one in this way, very easy. Right? I'll tell you where we have to put separations. Normally in here, like this, we have to put the separations. When there is a double bond like that, we have to put a separation. So when we are writing this kind of a long linear chain for alkanes, alkynes, you can just write down as it is. If you write down in this way also, correct. Doesn't matter. Okay. So it will take some time to practice these things. Doesn't matter. So today is the first day. It's okay, fine. We are doing some conversion practice, reaction practice also. So don't worry. In the whiteboard, I'm going to write down so many molecules. So you have, yeah, one more thing. Take a separate book for the organic chemistry. At least 200 pages. We have to do conversions that much. Okay. Right. Now quickly go for the tutorial. Turn to the page number 6. Students, they have given some points. Let's see what they have given. From above examples, it's clear that alkanes are a series in which 2 hydrogen atoms increases each time 1 carbon atom increases. Correct, Nid? When 1 carbon atom is increasing, each time what will happen? Each time 2 hydrogens are increasing. See here, I'm starting from methane, 1 carbon atom, and I'm going to increase another carbon atom. With the increment of 1 carbon atom, 2 hydrogen atoms are increasing. Go for the propane, 1 carbon atom is increasing. With that one, 2 hydrogen atoms are increasing. Go for the butane, another carbon atom is increasing. With that one, 2 hydrogens are increasing. So therefore, this is a series. This is a number pattern, mathematical series. That's why we obtain a common formula for that, CnH2n plus 2. Thus, this is known as alkane series, paraffin series, homologous series. Right? You have to familiar with these terms. Huh? Alkane series, paraffin series, and homologous series. Homologous. Right? Right? So, here I want to discuss about this term paraffin. Right? Have you heard about paraffin? Paraffin wax. It's a wax we are using in the chemical lab. Right? I can't remember whether I mentioned this one in organic chemistry. In order to store very highly reactive elements like sodium, potassium, rubidium, cesium, we are using paraffin wax. Paraffin wax are made by these kind of alkanes. Remember, students, these alkanes are actually very less reactive. They are low reactive. Do you know why? These are actually non-polar molecules. That means the carbon, hydrogen, electronegativity values are also not that much different. So therefore, normally we consider these kind of hydrocarbons are non-pole. That means they are not reacting. Understood? So therefore, we can easily store the elements like sodium, rubidium, cesium, potassium like elements in these compounds. So we are making the wax of these compounds, right? Some of them are available in the liquid form. Some of them can be converted into the solid form, right? So therefore, we can easily store these elements in the alkanes. So these paraffins means actually alkanes, another name that we're using for alkanes, right? So homologous means actually some kind of a technical term that we are using to show that there is a pattern followed by this carbon and hydrogen atoms. Try to understand, okay? So that's what they have given. The common formula for alkane series is CnH2n plus 2. Don't forget hereafter. Don't forget that one hereafter. Common formula is CnH2n plus 2. Please highlight that one. Students, please highlight that one. CnH2n plus 2. Only one structure can be drawn for each of the first three of the alkane series to match the molecular formula. Now, yeah, so this is how we are turning for the isomers, right? So look at the way that I'm going to approach isomers. Huh? Students, remember, yeah, right. Now listen to this one. CH4, C2H6, C3H8. Let me erase these things. Right. Now look at this one. Let me take the first one, methane. Can we draw any other structure for methane? Addition to this one? No. Right? We can't draw any other structure for methane. This is the only structure we can do. Let me take C2H6. Can we draw any other structure for ethane except this one? No, not possible. C3H8. Can we draw any other structure for C3H8? Anyone here? No. Students, remember, isomers means, can you remember we learned that resonance structures in Lewis structures. What does mean by resonance structures? Resonance structures means we are drawing the Lewis structure. We are drawing so many Lewis structures for the same molecular formula. So we are applying the same concept here. We are trying to draw different structures for the same molecular formula. But when you consider the first three alkanes in the alkane series, methane, ethane, and propane, we cannot draw any other structures addition to the structure that we have drawn. Only we can draw one structure. That means we have only one isotope, isomer. We have only one isomer for methane, ethane, and propane. Now let's go for the C4H10, right? Listen to this one very carefully. Yeah? Listen to this one very carefully. This is actually a peak point of the lesson. C4H10. This is the way that we are drawing isomers, right? C4H10, this is known as butane, right? Now look at this one. I'm going to draw a structure for butane in this way. This is the simplest structure we can draw, isn't it? This is the simplest structure we can draw for the butane. So if not, we can mention this one as CH3, CH2, CH2, CH3. Am I right? This is the structure we can draw for butane. Can we draw any other structures for butane? Can we draw isomers? Same molecular formula, but different structures. Yes, we can. We can draw. Look at the way. Look at the way I'm going to do. Remember, students, in the butane, you can see that the carbon chain is containing 4 carbon atoms. 1, 2, 3, 4. There are 4 carbon atoms. Look at the way that when we are drawing isomers, we have a method to draw isomers. We can change this carbon chain. I'm going to make shorter. I'm going to make shorter the carbon chain. Look at this one. Huh? We know that here we have CH3 group, right? Let me circle that one in this way, CH3 group. And can you see that we have hydrogen group here in this way, hydrogen atom. What about if I change these two species in this way? I'm going to put the hydrogen instead of this CH3 group, and I'm going to put this CH3 group instead of hydrogen. Shall we try? Shall we try to draw the structure then? Now look at this one. CH3, C. So this is the structure that we change here, CH3. And here we have CH2. And this is the hydrogen that replaced. And hydrogen. Now can you understand the carbon chain? Initially the carbon chain was 4. There were 4 carbon atoms. Now in the carbon chain, there are only 3 carbon atoms. Long linear one, linear. Right? So here we have carbon, we know that one, but it's not connected to this one directly, no. Now this is kind of a branch. This is kind of a branch for this long linear carbon chain. Right? So this will be very important when we go for the nomenclature also. So this is completely different from this one. Right? Look at this one. Huh? I'm going to draw the short form of the structure, then you will understand more. CH3, C, CH3, CH3H. Now can you understand what I have done? Make CH3, this one. CH3, this one. Upper CH3, this one. And the hydrogen. Can you understand? Then this is the central carbon atom. Look at the difference between the first structure I have drawn and the second structure I have drawn here. Completely different, right? Same molecular formula. This is continuously, you can see that 4 carbon atoms are there. Continuously, you can observe 4 carbon atoms. But here, what happened? I changed the carbon chain. I changed the carbon chain. That means I'm going to change the structure of the compound. If you are changing the structure of the compound, we consider those isomers are constitutional isomers or else structural isomers. I will discuss isomers separately. Isomers are divided into 2 parts. Structural or constitutional isomers, then we have stereoisomers. Structural isomers are 3 types. Position isomers, chain isomers, position isomers, functional group isomers. Stereoisomers are 2 types. Diastereomerism, if not we can tell geometrical isomerism. Then enantiomerism, if not we tell optical isomerism. Don't worry, we are going to learn those things after the identification of all the compounds. Here I want you to understand here, isomers are existing even in the alkane, even in the most simple form of the organic compound. Type. Alkane is the most simple compound type. So therefore, isomers are very, very, right? So look at the way that I have changed the structure of the carbon molecule by changing the carbon chain. These kind of structures are known as, these kind of isomers are known as chain isomers. If you are changing the carbon chain, then we consider this one as chain isomers. Can you understand? I will discuss these things separately under the isomers, right? So what are the doubts you have? Can you understand what I have explained here now? Let's see in the chat box, I saw some doubts. Yeah, butane have two different structures. Yes. So what happened when doing the same swap for propane similar to butane? We can't do that. You try that one, will you? You try that one, same thing will happen. I'll show you that one. Wait, will you? So can we also take two carbons in linear structure, right? No, we can't take two carbon atoms. Because there are four, maximum we can take is three in the butane. You can try that one if you want. So why can't this be done done to C3H8 as well? Okay, so most of you have doubt with C3H8. Wait till you. So can't we exchange for CH3 with another hydrogen? So can we replace that CH3 to a different hydrogen atom? Yes, we can do that one. Right. Wait, will you? Okay. Now, forget about butane, will you? First of all, I'll discuss this one again. I'll come to C3H8. I'll come to C3H8. Since some of you have the doubts in C3H8, I'll come to that. Yeah, that's a good point. I expected that from you. C3H8. Now I told you that we can't do the we can't draw the isomers for C3H8. I told you that this is the one and only isomer that we can draw. So some of you that are arguing that, so can't we do that, the breaking branches, same as we did for butane. Let's look at the structure for propane, CH3. So this is the structure, right? This is the shortest form of the structure. So there is an advantage of drawing the shortest form of structure. Okay, you can understand that one, right? Now let's break the carbon chain. Now there are three carbon atoms. So let's try to reduce this one into two. Then we can draw the isomers. Let's try. So I'm going to break this one from here. That means I'm going to choose this one. So as before, which carbon atom you want to remove here? What do you think? Which carbon atom you want to remove? This one? Or else this one? Whatever you want. Let me take this one, no? Right? Is it okay? I'll take first of all, I'll take this one first of all. And then I'll come to this one next. I'm going to change this one here and I'm going to put this one here. Then what will happen? CH3 will come here, right? Now look at this one, this group, disconnecting from here. So then you have to take that carbon atom and connect to here. Okay. And hydrogen should be connected to here. Students, don't you think that this is the same thing as this one? This is the same thing. You just imagine, now we had a line like this. Now this is some kind of a bend. So when you again form the linear one, you have the same thing, right? That means we can see that the CH3 group here, this one, and this is the CH2 group, and here CH2 and the hydrogen, right? So spread this one again, me. I'm going to take this one. Now this is 90 degrees Celsius. I'm going to put that one into 180. Then you have the same thing. Ne? That means when you draw the molecular formula, again you have me CH3, CH2, CH3, right? In the butane one, in the previous one, we had the carbon here. Then we can't take that one, right? So this is actually a linear carbon chain, long linear carbon chain. Continuing, 1, 2, 3, directly continuing. If we have a branch only, we have the issue. So that means whatever you try in propane, you will obtain the same molecular formula, same structure. Can you understand? What are the doubts you have? Right? Let me try to exchange this hydrogen. Now, not this one. Let me try to this hydrogen, exchange this hydrogen with this alkyl group. Let's see what will happen. CH3, CH, CH3, hydrogen here. Students, this is also previous thing, me. Opposite term, me. You can see some kind of a bend shape. But when you take this one into 180, what will happen? Same thing you will obtain, me. CH3, CH. Let me take that hydrogen here. So can we do like that? Yes, we can do that one because we have to take the continuous carbon chain. No? That means carbon chain is not changing. Same thing. That means this is also same as this one. CH3, make CH3, CH2, CH3. Can you understand? So therefore, whatever you try in propane, you will obtain the same structure. You are not changing the structure. So I think in the propane structure that we drew previously, we had 3 carbon atoms in the same line. Yeah, same line means doesn't mean that that is linear. Linear means one after the other. Continuity, right? Same line doesn't mean that linear. So linear means continuity. It can be in the either in this form also. Okay? 1, 2, 3. Continuity is there, right? So this is in the same line, but here we have 2 carbon atoms in the same line, and the third one is bent. No, no, no. Remember, even though that carbon atom is bent, we can see that it is in the linear form. So in the butane also we had the same thing. No, I'll show you. I'll again go to the butane. Then you will see there. Right? Again, I'll go to the butane. Butane is actually, we don't have a linear one. It is branch. Now, this is actually at the end, no? Right? That bent one was at the branch in butane. Right? That means when you shift this CH3 group to here, now it becomes a branch. Right? In the butane, C4H10. So therefore, whatever you try in propane, you won't obtain any isomers because you obtain the same structure, right? Can you understand? Please raise your hand who understood this one, please, honestly. If you can't understand, tell me. I think I went for the depth of the lesson a little bit, but it's okay, fine. If you have any doubts, put your doubts in the chat box quickly. Okay, right. So it seems you don't have any doubts here. Then now let's go for the butane. Right, okay. So before that, go for the paragraph they have given in the tutorial. Only one structure can be drawn for each of the first three of the alkane series to match the molecular formula. That's correct. However, the fourth alkane butane can have two different structural formula. Thus, when different structures exist for the same molecular formula, they called structural isomers or else constitutional isomers. Highlight that one, structural isomers or constitutional isomers. We are going to discuss that one further in detail at the end of the lesson, right? Now, let's start to draw the isomers from butane. Here I have chosen three molecules, butane, propane, and hexane. I'm going to explain these things. Let's see. Example number one. C4H10 butane. You can't see that. Right? Now, so as we discussed, this was the structure that we drew for butane. Okay? CH, CH3, CH2, CH2, CH3. Remember, students, this is known as N-butane. What is N-butane? What is for N? N means normal butane. That means we have abnormal butane. Yes. For the abnormal butane, we have something else. Yes, Sinetma, what is the doubt you have? So if butane is having three structures, pentane and hexane having three or four structures, right? Wrong. You try. It's not correct, Sinetma. But I really appreciate that question. You try. If you are done with butane, I have given you space in the tutorial. Try to draw the isomers for pentane, structural isomers for pentane. What you have to do, I'll give you the hint. Try to change the carbon chain. Right, now look at this one. Those who didn't do butane, look at this one now. There are four carbon atoms. Fix four carbon atoms are there. What I'm going to do here is, I'm going to break this CH3 group. I'm going to take that one out, right? So remember, students, it's no point of changing this CH3 with the adjacent carbon atom because we are obtaining the same thing, right? There is no point of changing the CH3 group with the adjacent carbon atom because we are obtaining the same thing. So therefore, go for the next one, right? One after the other. Then, sir, can we choose either hydrogen atoms? Arbitrarily, we can choose upper one or down one, both. Yes, whatever it is, doesn't matter, right? So therefore, let me take here this one, this carbon atom, and I'm going to replace one of the hydrogens with this CH3 group. Then you can put the hydrogens here and CH3 group here. Then you will obtain a structure like this. CH. Here we can see that CH3 group And here we have CH2, CH3. Can you understand? We can draw pentane in how many ways? Yes, Ashik, you are correct. So what it's they are also having, yeah, Asma, correct, correct, right? So now can you see that? Can you see that the groups that I've exchanged? May now let's see that linearity. Let's see that linearity. In the propane, I told you that whatever the whatever it is bento, whatever the shape, you should see the linearity. Linearity means continuity. One after the other. This is the first carbon atom. You can choose one of the carbon atoms from the end. Let me choose. We have actually we have three edges. You can choose this one, or this one. Let me choose this one. Now. One, starting from this one. Two, now we have a junction. Can you see that? Now we have a junction, kind of a wide four-way junction. Now we have to go for two roads. Actually, we have two roads. We have to choose one. At the same time, we can't go for the two roads. So we have to choose one. Then let me choose one of them. So what do you want? Shall we take this one? This is the third one. So therefore, this is the linearity. Only three carbon atoms. Can you see that the carbon chain has been changed? Carbon chain, the linearity is changed. Four carbon atoms were there. Now we have only three. So then what about this carbon atom? Then this carbon atom is becoming a branch. This becomes a branch. This carbon atom becomes a branch. Right? Now, with this one, I'm going to draw this one. Now. Look at this one. CH3, C, CH3, CH3, H. Harini, you can see that you have only one way, right? If you want, you can go for this upward direction, or else you can go for this direction. 1, 2, 3. If you go for this direction, you will have 1, 2, 3. Then this becomes a branch. Can you understand? Right? 1, 2, 3. Linearity. There were four carbon atoms in the parent carbon chain. This is known as parent carbon chain. There were four carbon atoms in the parent carbon chain. Now we have only three. The remaining carbon atom becomes a branch. You can take either this way, this kind of a L shape, or else this kind of a straight line. Whatever you wish, doesn't matter. Whatever you, or else we can take me CH3, CCH3, CH3. This is related to the nomenclature also. I'm going to take, this is the first carbon atom, second one and third one. Right? This way or this way. You can't go for the both side at once. Not possible. That's why I told you. But in the propane, it's what like it wasn't like that. In the propane, you had clearly an option to go for that third carbon atom. There were only three carbon atoms. Four carbon atoms now reduced to the three carbon atoms in the parent carbon chain. Other carbon atom becomes a substituent when we are drawing the structural formula. Right? Can you understand? This is completely different from this one, neighbor. These two are completely different from each other. Therefore, we can draw two isomers for butane. Try to understand. Two isomers for butane. Right? So the name for this one, this is N-butane. This is known as isobutane. This compound is known as isobutane. Right. Quickly complete this one. Now try to draw the structures for pentane. So can't. Right, okay. So Gimani, are you asking about this hydrogen? Ah, right. Now listen to this one. So we have a doubt here also. Can't we change CH3 with this hydrogen? Let me try that one. Now, Gimani, count the number of hydrogen atoms, carbon atoms in the chain. We can start from here. 1, 2, 3, and you can go up. Then how many carbon atoms are there? 4. That means you have obtained the same thing. ඒ කියන්නේ මෙයාව පල්ලෙහාට දාන්න. මෙයාව මෙහෙම පල්ලෙහාට දාපුවා bend කරන්න පුළුවන් නේද? We can bend this one. And then again we have CH3, CH2, CH2, CH3. No way. It's not possible. Definitely we have to take the middle carbon and the hydrogen. Right? I told you that we can't take this one also. Then also we are obtaining the same thing. Right? Yeah, only two structures. Only two structures for butane. So that means if we draw more than two structures for the pentane, it obtains the same structure as its isopentane. No, Sinetma, I couldn't understand your question because for pentane we can draw three structures. Okay, pentane we can draw three structures. Right. Now, listen to this one. Shall I teach you a small trick to get the answer easily? Small trick without going for this one. You have to know this one because this is very important when we go for the nomenclature and the isomers part. So this is actually depth of the part, depth of the isomers. But I'll give you a short trick for this one. Now listen to this one again. Students, remember I'm discussing these things again and again. I'm going to teach you these things for like babies because I want all of you to understand this one, right? Right. Can you remember I told you that the short of form of the structures can be drawn in this way, right? Can't you think about this structure? There are 4 carbon atoms. There are 4 carbon atoms. You break one CH3. Okay, you break one CH3 and exchange that one with one of the hydrogens. You take one hydrogen from this. There are 2 hydrogens. There are 2 hydrogens, right? You take one hydrogen there and connect this CH3 there. Then remaining hydrogen is there. CH2 also there. And connect that hydrogen here. Then CH2. Done. So that means without writing hydrogen here, we can write down that hydrogen here also. Yeah. So these are only for the organic chemistry. Yeah? These are unique for organic chemistry. We can do like that. Can you understand? Normal butane, isobutane. Right? Now you try for the other carbon atoms. You are going to break this CH3 here. And you are going to take hydrogen from here. Then what will happen? Okay. I'm taking this carbon, okay? I'm going to take this carbon. I'm going to take this CH3 group and connecting that one here by taking one hydrogen, then CH2. I removed one hydrogen, then connected CH3. Okay, CH2. Then that hydrogen is coming to this carbon atom, CH3. Iting lamai same thing neme. You put this on there. You put this on there. You can connect this CH3 group from upside door, downside door, left hand side, whatever the side. Same thing. That's why I told you. Gimani, I think you can understand more. एक මෙහෙන් කනෙක්ට් කරත් එකයි මෙහෙන් එකත් මෙහෙන් කනෙක්ට් කරත් එකයි මෙහෙන් යටින් කනෙක්ට් කරත් එකයි. Same thing. Can you understand? Right. Shall we try this method for the pentane? What do you say? Without drawing that bonds and everything, shall we try this method for pentane? Look at this one. Remember, students, so some of you gave me the answer that pentane can draw for 3 structures. Let's see. Pentane is C5H12, right? Pentane is C5H12. So what is the normal structure? CH3, CH2, 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 CH3. So this is the structure. Normal pentane. Right. Where to connect this CH3? I'm going to break this one. No point of the giving carbon, this group for this adjacent carbon atom. No point of giving this CH3 for the final carbon atom. Then you have to choose either places, this one or this one. Am I correct? I told you that there is no point of connecting this CH3 group for the adjacent carbon atom. There is no point of connecting this CH3 for the final carbon atom because we will obtain the same thing. Therefore, let me choose this one, right? Let me choose this this carbon atom. There are 2 hydrogens there. Remove one hydrogen. Remove one hydrogen and give that one for this carbon atom. Then what we'll have? Others are remaining as it is. CH3, CH2. We have one hydrogen now. And I connecting this CH2 here. Hydrogen is given for this CH3. Okay, ne? Hurry, ne? Now count the parent chain. In the parent chain, therefore 1, 2, 3, 4 linear carbon atoms, 5. 1, 2, 3. You want to go upside, if not directly in a straight line. So let me take the straight line. Then how many carbon atoms are there? 1, 2, 3. Can you see that the carbon chain has been changed? This becomes a branch. Right? This is known as isopentane. Students, we can draw another structure. Why? I told you that we can shift this CH3 for this carbon also. Right? Shall we try that one also? But interesting thing will happen, okay? You see that one? Some interesting thing will happen. Look at this one. Huh? Now I'm going to connect this CH3 for this one. CH3, CH3, CH2. Then that hydrogen atom should come here. CH2. One, two, three, four, branching. What do you think about this one and this one? Huh? What do you think about this one and this one? When you keep mirror in front of this one, you will obtain that one. Same thing. No point of drawing a structure by connecting this CH3 to here after drawing a structure connecting to this carbon atom. No point. So, but you said that 3 structures can be drawn. Now you are telling that this is same to this one. Okay, it's okay because there are 4 carbon atoms in the parent carbon chain. Right? So therefore, when you put a mirror in front of this one, you will obtain that. So therefore same. Then forget about it. Students, these are constitutional isomers. We are going to change the structure of the isomer. 1, 2, 3, 4, 5. 5 carbon atoms were there, right? 1, 2, 3, 4. I reduced that one into 4. Why didn't you try to reduce that one into 3? We can reduce this one into 3. How we can do that one? How we can do that? Huh? Yes, very good. Yes. Now we have obtained isobutane. In isobutane, I'm taking this CH3 group and connecting that one for this carbon atom. Look at this one. Huh? Look at the way that I'm going to draw this one. I'm going to take this CH3 and I'm going to change that one with this hydrogen, and hydrogen is going there. Then we can see that CH3, this hydrogen is going for this carbon atom. CH3, CH3. Now this CH3 is coming here, ne? Look at in the parent chain, how many carbons are there? 1, 2, 3. If you want, you can take upside also, ne? 1, 2, 3. Then this becomes a branch, right? If you want, you can take downside also. 1, 2, 1, 2, 3. Can you understand? Right? Then this kind of a structure is known as neopentane. N-pentane, normal pentane, isopentane, neopentane. Can you understand? 5 carbon atoms were there. Continuously, linear 5 carbon atoms were there. We reduced that one into 4. Then again, we changed that one and we obtained 3 carbon atoms in the chain. These 3 becomes branches now. It is not included for the parent chain. Neopentane. Please raise your hand who drew these 3 structures before I draw it. Please raise your hand who drew these structures before. There are many. Very good. Yes. Very good. There are many. Nice. Right. Please raise your hand who understood this isomers part for the pentane. Quickly. And if you don't understand, put your doubts in the chat box. Please raise your hand who understood this part clearly. Right. Good. Okay. So let's discuss about isomers more. So very interesting questions are there. So let's see. Okay. Remember, students, these are some thinking patterns. Okay. You have to click the pattern. You have to understand the patterns. So the normally what will happen is in school, actually in school or in some other classes, they won't give you these tricks. They won't teach you these patterns properly. Right? They will just give you the structures. These are the isomers. That these are the structures we can do. That's all. Right? So here my intention is you to understand these thinking patterns, how these things are coming. If they ask isomers, what we have to do? Simply what you have to do is you have to break and put everything that you draw in everywhere where possible and check whether you can draw the structures. That is the simple concept. This simple concept is not accepted by many students. That is the thing. Right? Now, after today's class, you have to try whether even I'm telling that, even after I'm telling that propane cannot be drawn, many isomers, you have to try and check whether, because from that one you can learn many things. Neither. So remember, when you are trying something, remember you are learning many things. It's not about the final answer. You are learning. Learning process is very important. So that's what we are discussing here. Learning process. Okay. Going for the answer is separate thing. Learning process. Okay. Neopentane. Right. Now, before we end the class, let's go for the hexane also. So tell me, anyone, how many structures you drew for hexane? How many structures you drew for hexane? How many structures can be drawn? So I got only three, four. Hmm. Right. Try that one also. So Vidara, a neopentane is obtained. May look at this one. Now we got isopentane. In isopentane, I change this CH3. I exchange this CH3 group and this hydrogen. මෙතන hydrogen එකක් ඉන්නවනේ. මේ hydrogen එක මේ CH3 group එකත් එක්ක exchange කරගන්න. Right? Then just imagine, think in your mind, hydrogen is coming to this CH2, then it becomes CH3. And this CH3 is now going for this middle carbon atom. Then this is the CH3. Then can you see that one carbon atom is surrounded by four CH3 groups? Then this is known as neopentane. And that carbon atoms contain a linear chain 1, 2, 3, or else 1, 2, 3, or else 1, 2, 3. Others are becoming branches. That's what we discuss under the neopentane. Okay. Students, please try these things at home again. Huh? Don't think that here after the class everything will be okay. You have to try. Try to draw the structures for hexane. No, Gimani. We have more than three. We have more than 3, 4 hexane. We have more than 3, 4 hexane. Yeah, most of you are telling that we can draw 4 structures. Let's see. Let me choose this final CH3 group. Okay, we should not always choose this one. Let me choose this one also. Doesn't matter. Let me exchange that one with this carbon atom, okay? And one of the hydrogen will come here. Then CH3, CH, CH3, CH2, CH2, CH2. That's fine. Eh? 6 carbon atoms reduced to 5. Here they have a 6 there. 1, 2, 3, 4, 5, 6. Let me try to reduce this one into 4. Look at this one. Let me choose this CH3 group and I'll exchange that one with this carbon and hydrogen comes here. Okay, fine, right? So this hydrogen can be drawn in this way also, but rather than writing in that way, this is convenient for us, right? Now, okay, then how many carbon atoms are there? 1, 2, 3, 4. Reduced to 4. Okay. Then I'm thinking another way. Look at this one. Look at this one. In this structure, let me shift this CH3 group now for the second carbon atom. Then hydrogen is coming there. Okay, ne? Right? So these two structures are different. So here also we have 4, but this one and this one different. Huh? The 4 structures I have drawn, they are completely different. So this is a little bit complicated because we can draw so many structures. And you told me that 4 structures can be drawn. Did anyone here draw 5 structures? Is there anyone who drew 5 structures? Students, why didn't you realize we can draw structure by shifting the CH3 for 4th carbon atom? CH3 and that hydrogen is going there. CH2, CH3, CH2, CH2. Right. Here we can see that 1, 2, 3, 4, 5. 5 carbon atoms are there, but different. This one and this one different. Eh? That means what I have done here is, look at this one, what I have done. I have taken this one out and connect this one to here. Mama make a methane galola. I have taken that one from the second carbon atom and connected to the third carbon atom. That's what I have done. These are known as position isomers. Position of the carbon chain has been changed. Second carbon atom, this substituent were in the second carbon atom. Now that substituent, the branching one is in the third carbon atom. Right? We didn't discuss about the position isomers yet, later. But anyhow, you have to understand that we can draw that one. That means isomers means we are removing some species and exchanging with the others throughout the compound, everywhere in the compound process. Likewise, we can draw 5 structures for hexane. Please raise your hand who drew 5 structures for hexane here. Anyone? Reshma, very good. Very good. Nice. Okay. So students, you have to practice these things. Huh? Okay. So I'm stopping from hexane. So because if you go for heptane, actually, again, we have more than that. Remember, so when the number of carbon atoms are increasing, isomers are also increasing. In the tutorial they have given, so remember, if there are 10 carbon atoms, that means molecular formula is C10H22. So there are 74 isomers, structural isomers. Oh my God, 74. So therefore, in the examination, they won't give much, right? Up to hexane, they are giving. Then if there are 20 carbon atoms, just imagine how many structures are there. In your resource book, they have given 866,318 structural isomers dead, right? You can draw these structures lifetime, right? In your lifetime. Now remember, actually, we don't have to draw these things. Now we have a branch in chemistry known as computational chemistry. So these are now computerized. So therefore, from computers also we can get these structures. Okay. So therefore, try to understand. So therefore, we are not going this much far, but you have to understand when the number of carbon atoms are increases, uh, isomers are increasing. So we discuss up to C16. So C6 to C10, not that much far, but number of isomers has been increased up to 74. For hexane, we drew only 5. Okay? For decane, we are drawing 74 isomers, structural isomers. So that is the thing you have to understand. Quickly complete this one. Hexane. Right. Finally, they have given 3 bullet points. Let's see. The alkane with 10 carbon atoms, write on the molecular formula in the brackets. So on the second one and the fifth one, same. Second one, that means you are referring which one? This one and this one. Upeshani? May then other. Are these two structures? No, they are not the same. As I mentioned you, may. So this is the branch. Make a branch. Here we have CH3 branch. That CH3 branch is connected to which carbon? 1, 2, second one, right? In this structure, this is the CH3 branch, and it is connected to 1, 2, 3. Third one, right? No, you can now you can argue with me that sir, number of carbon atoms are same in the parent carbon chain. Yeah. Even though number of carbon atoms are same, structures are completely different. We have to consider the branching also. Here the branch is connected to the second carbon atom. In here the branch is connected to the third one. So there is a clear difference. Neither. Can you understand it? Third one and the fourth one also, we can see that there are 4 carbon atoms. But the branching is different. This branch, CH3 branch, connected to the second one and third one. In the fourth one, both the branches are connected to the same second carbon atom. Naming for this hexane, this is normal hexane. And this is considered as isohexane. And this is considered as neohexane. Normal hexane, isohexane, neohexane. For these two structures, we are giving the IUPAC names. Right? I'll teach you what are the IUPAC names under the IUPAC nomenclature. Normal hexane, isohexane, neohexane. Okay, Nick? If you have any doubts, tell me, students. Now you have to try these things. Huh? As a homework, you can try for C7, H16, how many structures you can draw and send me the answers. Let's see. You try that one as a homework to practice isomers. Okay. Right. Okay. Now go for the next bullet point. The alkane with 10 carbon atoms. I have given you a bracket. Write down C10H22. Have 74 structural isomers, and alkanes with 20 carbon atoms, that means C20H42, has 866,318 structural isomers, right? It is clear that as the number of carbon atoms in the alkane series increases, the number of isomers increases very rapidly. Yes. And this is why the number of alkanes is too large to express numerically. Since the number of organic compounds is very large, there is a need to study them separately. Our next topic is identifying the types of organic compounds. We are discussing this one in the next Tuesday class, morning class, right? Okay, so actually today I was planning to discuss this part only. So correctly, by 11, this is over, right? So first of all, tell me, can you understand the things that we discussed today? Do you have any doubts? Please raise your hand who understood the things that we discussed today. Right. And students, I need a help from you. Give me a comment, a feedback about the today's lesson. After the class, send me a message. Put a message into the WhatsApp group. How was the today's lesson? Starting of organic chemistry, was it good or bad or whatever it is? A feedback, kind of a comment, honest comment. Put that one into WhatsApp group. Okay, I want to know that one. How was the today's session? Right. Right. Then we are meeting again on Tuesday, as we discussed. I told you, I'm going to put some extra classes. So therefore, Tuesday morning, 9 to 12, again 3 hours, we are doing that class, right? In case if you can't attend for that class, I will put the recording. Same day I will add the recording. When you come to the next Saturday class, before that class, definitely you have to watch the recording and come up. Right? If you come to the class without watching that recording and come to the class, you won't understand anything. So therefore, please, if you can't attend for the Tuesday class lively, watch the recording, right? Right. Then, okay, let's meet on the next Tuesday class. Until then, bye-bye. Have fun. Good night. Okay. Good night. Good to see you.